All right, welcome back to physics. We're now going to do lesson 3, which really is the beginning of physics. Like, you know how like we were just doing units, we're doing how to express really big number using scientific notation. We're now actually moving into physics. And so the 3 key terms, which if you remember from the activities, you would have kind of talked about position, distance, and displacement. Okay, so the unit that we're moving into, which is unit 2, is called kinematics. Okay, so kinematics is the study of motion or how an object moves. We're not really talking about why it moves. We will be in a minute. Okay, and we will be dealing with motion with the change of position. So what kind of thing are we going to be talking about in kinematics? Okay, we could be talking about this thing called time. And we use the symbol of triangle T. Delta T means change in time. We won't be saying right now, but we'll be saying in 3 seconds you've traveled so far. So that's why we need the triangle thing, because time is always an interval. Okay, the other thing that we're going to talk about is position. We would actually use a D, and because it's a vector quantity, we would put a little arrow at top just to represent that, oh, this one has a direction. If you remember what scalar and vector means, that's what they mean. Other things that we could be talking about is how far did it move? And that's displacement. Okay, and we also could be talking about, well, how about total distance? Distance is very similar. If you remember, if I'm saying like, hey, tell me what the answer is, it's delta D is distance. Okay, so we don't have an arrow because distance doesn't have a direction. It's like a length. Other things that we will be talking about in this course is the rates. How quickly is something speeding up? I don't know if you know what it is. Like say a Ferrari. Ferrari is really expensive because it can speed up so quickly. Okay, we use the term acceleration, so a letter A with an arrow, or we're saying how fast is the Ferrari going. We could be talking about what is the velocity. Okay, so these are all the things that we would be studying in this unit called kinematics. Okay, already talked about this. You all actually wrote it out and did a little activities on it. What is scalar and what is vector? Okay, scalars are things that has no directions, so it only has a magnitude, and it would also have a unit. So an example of a scalar quantities, we already talked about time, right? Time is not a vector, it's a scalar. And what we do is we would write something like 5 seconds, okay? The 5 becomes a magnitude, okay? So that's the magnitude. The number is the magnitude. And then the unit is the seconds, okay? Vice versa, what is a vector quantities? Vector quantities has magnitude and direction. On your note, can you make sure you're adding this in? You can use the text box or whatever. I need you to add it in and say that it also has to include a unit. Okay, so there's 3 things a vector would need: magnitude, unit, as well as the direction. And direction is probably the most important. Okay, and direction can be described in many different ways. You can say forward, north, south, going down. Okay, and we usually use a square bracket to represent something is a direction. Okay, right after the number or the units. All right, so specific definitions. What is a position? We use the positions with a symbol of D with an arrow. Okay, it's telling you where it is, location of the object. But very importantly, if I say, Peter, I'm going to meet you at 2 meters. You'll be like, where? You know, where am I meeting you? But if I say, Peter, can I meet you 2 meters north of Dixon and Roslyn? Okay, now I have a reference point, right? I tell you where it is referring to and how far away that you're going. Okay, so it has to have a specific reference point. You can't just say 5 meters. Okay, you have to say 5 meters from whatever the reference point that you're talking about. So where is the laptop relative to the door? It's 2 meters right of the door. Okay, so the object, the laptop is the object 2 meters right from a reference point, which is your door. Okay, now distance and displacement. Distance, delta D, no arrow, so it is a scalar. So no direction. Distance is almost like a length. The length of my pencil is 25 centimeters, right? I don't need a direction to that. Okay, and then what distance in this case it's talking about is the total path that has been traveled from one position to another. Okay, so this person, he walks, so if I say this is northeast, southwest, okay, I'm just making things up. Okay, northeast, southwest. So he started here and travel a distance. He traveled towards the east for 10 meters, and then he travels towards the left or the west for 6 meters. If I ask you what is the total distance this person traveled, the total distance is delta D. Does it make sense that I would just add the 10 and the 6 together? Okay, so 60 meters is the total distance. There's no direction involved. You just add them all up. Then opposite to that is what is displacement. Okay, displacement is the change in positions. Position is where you're at, and you don't care what about the path in between. Okay, so this is what they're saying. Displacement is not concerned with the path taken. All you care about is where you started and where you ended. Okay, you started at the spot called D1, position number 1. And you always call the ending position D2 with an arrow. Okay, and the equation to work it out, I actually like to use the one at the bottom, and they made a mistake. They should put arrows on top. So these are all vector quantities. Be very picky on that. We're going to go back to the same example. Okay, this guy went 10 meters to the east, 6 meters to the west. We already worked out what is the total distance. Total distance is 10 plus 6. That's pretty easy to see. But how about the displacement? Displacement, go back to the definition. What is the change in positions? I started off at this point. Is it okay if I say that this is D1? The guy started at here. This is my D2. Where am I from my reference point? If I make like a little number line thing, let's do this guy, make it skinnier. If I make a little number line and I say that this is 0, if I started off at point 0, where am I now? I walk 10 to the east, 6 to the west. Is it okay if I say that I am right now standing at 4 meters east from my starting 0, from my reference point? This is my reference point. So if I ask you what is the displacement, how much did I change in positions? My displacement start from the 0 and I walk towards this way. How many? Did you say 4? Does it make sense? I started at 0. I know I walked 10 and 6, but I ended because all I care about is where it finished. So I ended at the 4. My change in position or displacement is called 4. All right, so examples now. What is the position of the car? Good practice when you do question is you highlight it. What is the positions? Okay, now go back. I need you to be picky on the symbol that you'll be using. Positions, we already talked about no triangle at the front. Position is D with an arrow. Okay, and when it's a 0, it doesn't say if it's northeast, southwest, left or right. It's up to you. Okay, you can decide. The position of this car is 5. They don't even give you a unit. Can I just ask you to assume that these are meters? Okay, I'm going to say this is 5 meters. I can say forward. Okay, just because it's a positive value, I'm just going to say it's forward. If you say right or east or north, I have to accept it because I didn't give you a reference. But if I did give you a reference of direction, then you have to obviously include and use the right one. Okay, all right. So what is the distance travel and the displacement if the car moved from left to right? Okay, so this time they have a reference, and there's 2 things I'm looking for. I'm looking for distance, I'm looking for displacement, and so let's write out our equation. Okay, distance, delta D, no arrows at the top. Distance, I started off at -4, and I move all the way to 4. The total distance, you can even just count. Or if you want to add 4 plus 4, 8 meters. It's hard to show the work for distance when you can just pretty much read from it, so I don't need it. Okay, displacement is the one that I will need an equation because there is an equation with this. Okay, so challenge you, write your symbol. What is displacement symbol? How do I write it? How do I write the symbol for displacement. Be very picky, 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 picky. Displacement is delta D with an arrow. I don't even want you to say triangle D. Get used to it. Delta is like a Greek alphabet. Say delta. So delta. Okay, that's how you say the little triangle. And what it means is it means the change in. Something is changing. So I'm changing position, so that's why it has a delta in it. The equation for delta D is D2 arrow minus D1. Okay, what is D2? So D2 is this point, right? The ending point, I ended at 4. So D2 is 4. What is D1? I did say please add in the meters as a unit. I just don't like it when they don't do units. Okay, D1 is my starting point, right? My starting point is D1. D1 is equals to negative 4 meters. Are you okay with that? All right. So D2 minus D1. Then now you plug in your number. Okay, be careful. I have a negative number. D2 is 4. I am subtracting. I have D2, which is 4, minus D1. What is D1? D1 is negative 4. You can punch it in your calculator if you want, but hopefully if you remember some math from before, when I'm subtracting a negative number, it really means that I'm adding. Okay, so 4 plus 4, that gives me 8 meters. Don't forget your direction. What direction would you put? Okay. We're assuming the positive value to be the forward, right? So in the question it says you're moving left to right, so the direction they would want you to do is use right. Okay, does it make sense that if I say where you started and where you ended, I can put in I started at 4 and I go towards the positive 4. Does it make sense that I'm traveling to the right direction? Okay, so anything I assume to be positive, if the value turns out to be positive, it is positive. Okay, I don't know if that's confusing. I'm going to do a quick example just to see if you get it. Okay, like you don't have to write this down if you don't want to. Okay, if I tell you that this is D2 and this is D1. Okay, and if this is 0 and I tell you that the car started at 3 and it ended at negative 3, I went this way. Okay, D1 is 3, D2 is minus 3. I plug it in the equation. Delta D is D2 minus D1. It's still always final minus initial. Final is negative 3. D2 is negative 3 minus D1 is 3. I get negative 6. Okay. Is it negative 6 to the right or is it negative 6 to the left? Okay, if you don't know it, that's okay, but I'm going to tell you right now, this is negative 6 to the right. But it also means if you look at the picture, if I have a negative of whatever the direction is, all I have to do is flip the sign and say that this is also 6 meters to the left. This is something that is a little bit more tricky. It's the negative of a direction. You can just drop the sign and flip the direction backwards. Okay, a person walks from her house to the store 100 meters away. So the store and the house is 100 meters away. She then walks 50 meters back towards her house. What is her displacement and what is her distance? Okay, they give you no sense of direction at all. So that means you can put whatever you want. Person walked from her house and a store. So I'm just going to assume my house is here. Okay, and they even tell you where 0 is. So it's easy to make one of it a 0. Okay, when they don't start the number line for you, you make it up. I'm going to say my house is at 0. Okay, then I travel to a store. I don't know how to draw a store. This is my store. Okay, the store is 100 meters away. They didn't even tell you northeast, southwest, forward, backward. I'm just going to say it's to the right hand side. Okay, she then walked 50 meters back. So she initially traveled, I'm just going to use another color. So she started off here. She goes all the way to the store. And then she walks back 50 meters towards her house. So now this person is standing right here. This is D1. This is D2. I need a value with it. You have set up a number line. So D1 is my house. I said I'm assuming it to be 0. If they didn't write it down for you, you just assume and put what you think is right. As long as you clearly show it on the picture, I can see it. Okay, 0 meters. And where is she now? She traveled 100, back 50. She is right now 50 meters towards the forward direction. It didn't say what it is, so I'm just going to assume that this way is forward for me. That's my assumption. You can say right, you can say east, whatever you want, because they didn't say in the question. I can't mark you off that way. Okay, so part A asks you for what is the displacement. Displacement is delta D with an arrow. The equation for displacement is D2 minus D1. Okay, D2, it's at 50, because see how with my pictures I clearly write out what they are before I do it. Okay, I would have lost half a mark. I didn't put the arrows on top of the position, so make sure you put the arrows on top of it. D2 is at 50, D1 is at 0, so 50 minus 0, I get 50 meters, and the direction is forward. So these are the little things. So make sure you put your direction. Make sure you have an equation. That's 1 mark. You would lose half a mark if you are missing arrow or missing direction. Okay, if on the answer part, if you're missing the direction when it's supposed to be, or backwards, if you're not supposed to have a direction, then you put a direction, you would lose half a mark. Okay, all right, so that's part A. Part B, what is her distance travel? Okay, so distance is delta D. I don't need you to write an equation for distance. You can just look at it. I travel 100 meters to the right, and then I travel 50 meters to the back. So I get 100 adding 50. The distance, I count all the leg. Okay, so 150 meters, no directions. Okay. Question 4. What is the displacement of an object if it moved from a position 10 meters to the right to the position 30 meters to the right? Quick number line. Okay, so what is the position? So if this is 0, I started at 10 meters to the right. This is my D1. And then I now move to 30 to the right. So 30 meters to the right. This is my D2. They ask for displacement. Displacement have an equation. I'm going to stop. You write your equation. What's displacement? Double check your symbol. Double check your everything. The other thing that I am concerned is some of you are already giving up on the Cami and you're not taking note properly. Please don't do that, right? If you don't have your Cami ready, honestly use a piece of paper. Or if you have access to a printer, print. I recorded these videos so that it's easier for you to follow and you can pause when you need. And I don't have to worry about technology, like stopping when I'm teaching and you can't hear me. I spend all this time because I want you to be able to follow along. So problem solved. Either print it out or you're going to go learn Cami, master it, take your time. Or if you really struggle with Cami, I know it's not the most easiest thing to do. Sometimes if you have trouble opening it up and stuff like that, can you use a pad of paper? Just label it. This is lesson 3 and write out your examples, which is absolutely fine, right? But you do want to look at these because I told you I'm picky on the format. So you actually get 1 mark for writing out the equation, okay? So you will need to refer back to your note. Okay, so D2 minus D1. D2 in this case, we already said is 30. D1 is 10. I have 30 minus 10, so that gives me 20. I write my unit down, and I write my direction down. Oh, we good? Okay. What is the displacement of an object if it moved from a position of 40 right to 15 right? Okay, now this is the tricky one. Okay, draw your number line. I was at 40, right? So I'm going to still put my 0. This is 40 meters. This is my D1, my first positions. And it is to the right. What this means is it's to the right of the reference point 0. Okay, now I am at 50 meters to the right of 0. This is D2. All right, so that means right is the direction that I'm using as a positive value. Equation for displacement is d2 minus d1. d2 is 15, d1 is 40. 15 minus 40 is negative 25. Okay, let's see if you get it. Negative 25 meters. Is it negative 25 meters to the right or left? You write it down first, and then I'll tell you what it is. Whatever answer you get is whatever the direction that you're using. This is negative 25 meters to the right. Well, you'll be like, hey, hold on. Why is it right? Well, I did go left. I did go D1 to D2. The other way you can write, I actually have to give you a mark if you write this. Okay, so this is already a 3 mark. You already got 3 marks. But if I'm like, okay, does he or she truly get what the direction means? This really should say equals to a positive of left. So to swap between direction, you can swap the direction by flopping the negative. Okay, so what that means is, okay, if I go really tricky, if I say something is 25 meters north, 30 degrees south. Oh, no, never mind. Don't do that. I'm going to mess you up. Okay, forget that I talk. Okay, if I say 15 meters south, I actually could say that this is the opposite, but stick a negative in front of it. Okay, so those are the rules. What is the displacement of the object if it moves from position of 12 right to position of 18 left? Okay, now I'm referring to the other side of the number line. What is the displacement? I'm going to put 0. I'm still going to say the positive is right. Okay, I was at 12 meters to the right. This is your D1. And now I am 8 to the left. 8 this way really means negative 8, because on your number line, I am a negative 8 to the right or 8 to the left. This is my D2. You will not get your answers right if you don't remember that the left and right, it's on the opposite side of the reference point. Displacement, I always write my equation. This is always 1 mark. If you don't write your equation, you don't get that mark. Okay, D2 is negative 8. D1 is 12, so minus a positive 12. Okay, so I get minus 20. Okay, right or left? Right or left? I know I traveled to the left. I know I went this way, right? D1 to D2. I started at 12 and I go that way. The answer is negative 20 right or a positive 20 left. You get used to the format. Okay, last question. A person drives along 401 starting in Toronto. They drive 35 meters east to Whitby, and then they drive another 10 kilometers east to Oshawa. Finally, they drive 20 meters west to Pickering. What is the distance traveled and what is the displacement? All right. Let's go east as positive, just because they started it. Okay, reference point 0. They started at Toronto. So this is Toronto. This is your D1. They drive 35 meters east to Whitby. This is their D2. And then they drive another 10 kilometers to Oshawa. Where is he now? I'm not going to write 10. I shouldn't write 10. I need to go back to the number line, right? If I was at 35, I travel another 10. This is now my D3. I'm using like 1, 2, 3, 4. The last number is like your final one. Okay, this is my D3. I am at 45. Do you see that? Okay, and then they drive 20 kilometers west to Pickering. So now from here, I'm just going to use another color. So from here, they travel 20 meters. This is 20 meters. The little pink thing is 20 meters. So I'm like right here. What is the number right now? What is the number right now? Okay, I was at 45. I now travel 20 towards the other direction. Is it okay if I say I am at a 25? And I am now at D4. Initial and final. Okay, so let's see. There's two parts of the question. So the first part, part A, they ask for what is the total distance travel. Okay, I didn't add in my little value. Maybe I should have written it in. So the light pink is 20. Okay, so take a look at the entire trip. Went from 0 all the way to 45 and then come 20 this way. So my answer, my total distance travel, I have traveled 45 at the beginning. So 35 plus 10 if you want. And then I'll travel another extra 20 backwards to the other direction. So 65 meters, no direction. This is distance. It's a scalar quantities, no direction. Okay, part B. What is their displacement? Okay, displacement, it's starting point to ending point. Equation for displacement is d2 minus d1. d2 in this case, it's 25. I know I said d4. This is your d2 in the equation, the final positions. Okay, minus the initial, which is a 0. So I have overall changed my position 25 meters. Oh, what direction? East.